And here are the solutions to worksheet 10.2. Just go ahead and read over these. Some of these are very self-explanatory, but I do just want to re-emphasize number 2, that this is just the slope-intercept form of an equation we're using in statistics. Technically, yes, it's y equals mx plus b. Just to remind my calc students, this y prime or y apostrophe is not a derivative. And then for 5 through 8, again, pause the video or go back if you need to look at the others. But what I also want to point out for number 6, r and the sine, or the sine of r and the sine of the slope of our line of best fit need to be the same, because if r is positive, then we need to be able to draw on a line that's increasing from left to right, or a line that has a positive slope, and just the opposite if r is negative. And then also at number 8, if the value of r is not significant, what could be said about the regression line? Well, it's meaningless to try to draw a regression line in there if our points are all over the place and they don't look, it doesn't look like as x is increasing, y is increasing, or as x increases, y decreases. So if there looks like there's no relationship, having a line of best fit or regression line is meaningless. All right, at the very top, I just have the formulas again for A and B. Still practice. You could type into a list and spreadsheet the data values to help you find all these sums, but just know that I might ask you to show those in the formulas here. Now, when we do construct a scatter plot and a regression line, the calculator will show us, which is a nice way to check, which I have you guys doing for some of these examples. But before we get into number 10, for number 9, when the value of r is not significant, what value should be used to predict y? And that's just the point that's in the middle, so the mean of the y values. All right, so for some of these, I'm having you calculate, so use the formulas here, but again, you could go to a list and spreadsheet on your calculator or Google Sheet to help you find these sums. I know on a Google Sheet, you have to sort of type in the commands for this as well. There's still a chance if any of you guys still need calculators, I've got 8 of them here with me. I can find a way to get them to you. It'll make life a lot easier, especially for the final. So I will be sending out a reminder for that. All right, so for number 10, I just want you to find the y when x is 4 years, but we still have to go through and find the equation. So notice all of these values here that are necessary for both formulas. So here it turns out A is 453.176, B is negative 50.439. Remember, we're always rounding to the nearest thousandth here. Notice R is negative 0.813. So even if you didn't sketch a scatter plot, you can still find that R, and that's significant enough. That's pretty close to that -1 that tells us we should be able to see a trend with the points. So now that we have our equation written out right here, now all we have to do is substitute in 4 for x, and then we get the y value when x is 4. Now, number 11, R turned out to be 0.4. Anytime it's really between 0 and 0.5, or we even saw in worksheet 10.1, we had an R of like a 0.649 that still wasn't significant enough. So here, the R value is not significant enough to tell us there's a relationship between the variables, so no regression should be done. If you took the data values here and actually made a scatter plot on your calculator, that would also verify this statement. All right, for number 12, dealing with egg production, here we want to find the value of y prime when x is 1600 eggs. So here again, I have all the values off to the side and figuring out what A is and B is. So our equation is right here, and then all we do is substitute in 1600 for x, and then we get almost 62 cents per dozen. Now this last problem, I have you going through everything here. So first I have a relationship between the math and verbal on ACT scores. So looking at our scatter plot, again, make sure you still label. I'll be looking for that on a graded problem here. And then at the very end, I have this for parts, so don't look at the equation just yet, but notice if we plotted these points, yeah, they are far apart as far as where they start and where they end, but there is a trend that we could show our line of best fit is going uphill. Calculating R, we also see that that's significant enough. Notice I did state the null and alternative hypotheses. Now here I just use table I. That's, again, my preferred method with this. I think it's a lot quicker. Degrees of freedom are 4. And if we were to draw this out on our number line, our critical values with R being 0.990 is going to fall in that critical region. So our decision is to reject the null hypothesis. For E, these are all the values I need to find A and B. So calculating that. F, I just wanted you to do this on the calculator to show that these values match. So here we get the y prime is equal to a plus bx. So we're getting that 63.472 and then 0.900x. Now, when you go to do this on the calculator, it carries out, depending on what your float is set to, should carry the decimals out a lot further than what we have here. All right, and then for G is to summarize this. So again, pointing out our equation here. This is telling us if we reject the null hypothesis, we have enough evidence to conclude that there's a relationship that exists between verbal and math scores on the SAT. All right, guys, let me know if you have any questions. I will be posting solutions to the final exam review chapters 5 through 8 by Friday.